Hello and good day everyone. So we will now proceed to another topic under the engineering principle of AB structure design, which is the design of floor joists or inertia as a floor system. But we will only consider the designing of floor joist. Okay, so let's start. So what is floor joist? So in the floor framing, the subfloor is called under light beams called floor joist or simply joist, which is in turn supported by heavier beams called girders, then girder pass the load to columns. So joist and girders are beams. There are types of beams, so they only vary with size. So small lang ang floor joist compared to girder. So but there are types of beam. So since there are types of beam, the design process for this is just like what we did in our last topic, no, in designing of beam. So we will use that formula in designing also in floor joist. Okay, so this is the illustration. We have here this the girder here, and then this part. This is the floor joist. So we have the mid-span support. Then we have this column. Okay, so I have here another illustration for you to So this is the floor joist, and this is the girder, or another term for girders is bearers. So you have this column. So the design process for structural, no, I will just ako lang siyang ipakita dan. So from flooring, the floor load will transfer its load into the floor joist. Okay, then this floor joist will transfer the load from floor into the girders. Okay, then there's these girders will transfer the load into the column. So that's how you design. So transfer lang ng load niya. Okay, so typically joist act as simply supported beam carrying uniformly load. So uniformly distributed load. So it is very simple to because we already, or most of our example last time is about beams which is carrying uniformly distributed. So how to calculate its maximum moment? Just the WL squared over 8 for shear force is W over 2. Okay, so floor joists are used to support a floor span over an open area like over a basement, crawl space, or lower floor level, or between shed floor beams. So floor joist is a structural elements that will support floor system. Okay, so okay, it is part of the floor system, but its main job is to support the flooring. Okay, he carry the load from the floor then transfer it into girders. Okay, so wait. Okay, so this is the typical floor framing plan. So you have here the floor joist, its effective span or the spacing. We also have the girder, and we also have the column. We also have the effective length of your beam. No beam. Your floor joist. B also it's beam. Okay, so effective length. Okay, so from there, it is simply supported. If load is available, live load, dead load, then you can calculate its dimension. But before that, I will show you this table. This table is mechanical properties of wood. So I show you this because most of the time we use for a material we used for floor joists is timber. So every type of timber possess different type of properties. Okay, so in your AB materials, I think ma-discuss here. So there are many properties, no. So from density to allowable shearing stress, allowable bending stress of that type of wood. So you can look at this table so that you will be familiar. In a way, most of the problem will state the property of the material lang muna. Okay, so I think let's proceed to an example because as I said, it is only the process, the same procedure is almost the same when designing of beam. So I think the very best thing to do is to show you an example so that you can understand its design procedure. So I will read the problem before I will solve this. So wood joists are used to support a floor load of 6.96 kPa exclusive their own weight. 6.96 96 kPa exclusive. So, neglect muna natin yung weight ng beam or the purlin, the floor joist. Okay? So, the joist will have an effective span of 4.25 meter and be placed at 4 centimeter on center. So, spacing for floor joist is 40 centimeter, then its length is 4.25. The allowable stress are 10.35 MPa and 0.95 MPa for flexural and shear stress, 10.35 for flexural or the bending, and 0.85 for shear stress. We also have the modulus of elasticity, which is 12,135 MPa. And we also have here the allowable deflection, which is 9 mm. Remember that floor joists are simply supported, carrying a uniformly distributed load, and it is simply supported. So we already have the formula for deflection for that. Okay, so design a wood joist. So the problem asked you to design the wood joist. Then the weight, the raw spelling, the weight of the wood is 7.5 kilonewton per cubic meter. Okay, so that's the problem. What we need to do is just to design the dimension for our floor joist. Okay, so let's solve that. So let's solve that problem. So I have here, I draw the problem, the figure for the problem. So we have here, this is the floor joist and this is the floor deck. I also written the summary of the given. So we have the floor load, the length or the span of the beam. You have the allowable bending stress and the allowable shearing stress. We also have the modulus of elasticity and including the allowable deflection. And lastly is the weight of the floor joist. Okay, so first thing first is using this given floor load. Okay, so as you assume, this 6.95 kilonewton is in terms of pressure, so which means that this is for the entire floor. But during our analysis, we will only consider one floor joist. So therefore, out of 6.95, pila lang ang i-account sa isa ka floor joist. So therefore, we need to calculate that for this specific distance, which is for its spacing 40 centimeters. So how to do that? So first is just simply we will use the variable W, 6.95 kPa multiplied by the effective spacing rather, which is 0.4 meter. So we have W of 2.78 kilonewton per meter. Okay, so this is now the load that will apply in one floor joist. So if you will draw the free body diagram for that, you can have this figure. Okay, so it's again, by definition, it is simply supported beam lang ang floor joist. So therefore, you have this configuration. So with this configuration, you can calculate that its maximum bending moment is just equal to WL squared over 8. Right? In our previous discussion, then we will use this W, 2.78 kilonewton per meter multiplied by its length, which is the total length of this is 4.25 meter squared over 8. Then you have a value for maximum bending moment of 6.28 kilonewton meter. Okay, so assume that it is rectangular as we solved in our previous discussion, that we reduce the formula for rectangular beam, which is the maximum bending moment is just equal to 6m over b squared, right? So we have here the maximum bending moment for this is 10.35 MPa. Then we also have the maximum bending moment, which is 6.55. Then we can derive the equation for BD squared equals to a certain number. So using that, proceed to a design analysis. Then you set what is B, you trial and error the process. Then there you go. So, so I will show you. So 10.35, convert na to times 10 to the power 6 equals to 6. 6.28 easily understand, so convert lang na to. Newton per Newton meter. Then you have this BD squared. Okay? So 10.35, it is now Newton per meter squared. So we can derive the equation BD squared is just equal to here 3.64058 times 10 to the power of 3 meter cube. Okay, but in designing, it is the dimension for this floor joist is will not range to meter, so it's very practical to convert this meter cube into mm squared. So if you convert that, you will just multiply 1 over. So you have no, 1,000 over what? Mm meter. So you have 3,640 579.71 mm cube. So you have now the equation for this. So by process, we will try certain this dimension. It's either for B or D. So for me, I will try B equals to 50 mm. So what will happen? What will be the dimension of D if B is equal to 50 mm? So just substitute. So we can, I think you can solve that in your own. Substitute 50 to this equation, so we can have D is equal to 269 point, I wrote that, 84, let's just say 300 mm. Okay, so I adjusted because remember that we will account the weight of the beam. Okay, but during this process, I consider only the load alone, which is the floor load. Okay, so to take account the weight, I will adjust the dimension into 300, but we will check that later on if this 50 by 300 is safe to use. Okay, so to check, we will use the shear. So remember that the shear is allowable is 3 halves over BD. Okay, so that. But we have V, which is unknown. This is the allowable. So we will calculate now the V. But first, we need to convert this weight into uniformly distributed load for that beam. So wood joist is just equal to, let's say, 7.5 kilonewton per cube multiplied by the dimension, which is 0.05 and 0.3. So you have the area of, load area of 12 kilonewton per meter. So therefore, the total load for this structure will be add lang, it is 2.278 plus 0.1125. Therefore, you have 2.8925 kilonewton per meter load. Okay? So you have now the total load. So our objective is to calculate this V, which is equal to, for uniformly distributed load, it is just equal to WL over 2, in which W is 2.8925 multiplied by length na 4.25 divided by 2. So you have a V of 6.15 kilonewton. Okay? So substitute this in there. So I will erase this part because we are limited of space. Okay, so from there, V just equal to 3 over V is 6.15 over the dimension of 50 times 300. Okay, so since this is kilonewton, so we will convert that into Newton so that we will produce V is just equal to how many that? Just over that. So it's 0.615 MPa, which is less than 2.85 MPa. Okay, so this 0.85 is this allowable shear stress. Therefore, you can say that it is safe to use the dimension of 50 by 300. But we, given rin ang deflection. So let's check for the deflection of this structure. So check deflection. To check the deflection, you have y equals to no. Okay. So you have this deflection. So this is deflection class. It's from uniformly distributed. No? If it is simply supported, then uniformly distributed the load. Then you can calculate that the deflection is 5WL to the 4th over 384 EI, which is I is the moment of inertia. So we have here the 9. So what we need to do is to calculate given na ang atong load, given ang atong span, we have the modulus of elasticity, we can calculate the moment of inertia. If our deflection will be equal to 9 or less than 9. If it is greater than 9, then we can say that it is our load or our dimension is not safe to use. Okay? So substitute lang. 5. I wrote the simplest form here. Okay, so we have here there. The total is 2.89. So 2.8925 times 10 to the power of 3. L is 4.25. We will multiply it by 1,000 over 1. Cube to cancel. Then we have 384 multiplied by 12,135 times 10 to the power of 6. Its modulus of elasticity. No, the moment of inertia is. Okay, so I will erase this part. Then we will cancel 1 over 1,000 squared. Okay, this moment of inertia can be calculated using this formula. BD cubed over 12. Substitute of BD, then you can calculate that the moment of inertia is just equal. If you calculate that, it's equal to 9.00 mm. Therefore, it is equal. Therefore, we can say that since it is 9 mm, we can say that our dimension is set. We can use that 50 by 300 mm. So therefore, we can use that this is safe to use. So we can have it will satisfy the allowable, which is 9.00 mm. But for assignment for you, you try if the dimension is 50 by 269. So what will happen? Okay, so another thing. So if we did not adjust from 269 to 300, what will happen to our design? If it is safe to use 50 and 269.84 or not? Okay, so that's assignment for you. So that's all for design of floor joist. Thank you.